All right, hello class. Welcome to week three or lesson three. And in today's discussion, we'll be talking about different types of hard drives and using either hard drive or locally or cloud storage. So what I wanted to do is I wanted to discuss different types of drives, discuss some RAID levels and servers and how those storage on that works, and then discuss a little bit of cloud storage and cloud computing so that you have a better understanding to do your discussion. And again, I'm instructor Daniel Schmelling, and you are doing INT 1110 lesson 3. So if you'll join me here on the screen, I'll be looking at the screen. We're going to go over the different types of drives. So there's different types of hard drives, and the first one of what I want to talk about is the SATA one here. The SATA drive, actually, that's the type of attachment or type of connection. You can see that SATA pinned out connection there. And this drive actually spins like a record player. This is called a platter. And different drives will spin at different speeds. So the input output, which in drives is basically called IOPS, the input output of this drive, depends on the RPM of that platter spinning, much like a record player and a needle, right? And those items are being read. So they sell them 5400, 7200, 10K, 15K. But primarily, the higher the number, the faster the spins are, and the faster your input output is for that drive. So certainly performance is affected by the RPMs of the platter. So now we have this SCSI. This is normally placed in servers, SCSI drive. And it's just, again, the type of connection is a bit different, but this also has the platter that spins in it. You can see barely right there, it says 10K, so this is a 10K RPM spinning platter drive. Again, moving parts, depends on the speed. So what happened is, as technology advanced, we then came out with SSD drives. This is down here. It still has that SATA type connection, right here. So that SATA connection is how that plugs into the motherboard. But there is no spinning parts. It's definitely an electronic type of drive, right? So you plug it in, no spinning parts, and therefore the performance of the SSD is much faster, right? You don't have to wait on the platter to spin in order to get your IOPS, right? Your input output up and down, right? So it's a much faster drive. And then this right here is an external drive. It's basically comprised the same way, right? Nowadays they're making those all SSD type drives, solid state drives, where there's no spinning platters. It plugs into USB and then you have access. Now, as we've advanced more and more, there's a new type of drive coming out, and that's coming out in most laptops and desktops today. In fact, my desktop has one of these. It is called an NVMe drive, and here that is, right? So the advantage to this, of course, is that it's very small, right? So this actually looks like a stick of RAM, but it's not. It is not a SATA connection, right? This is actually a PCI or PCI Express connection, and therefore the IOPS, the input output, is not limited to the connection. So SATA is determined to move at only 1 gig, right? 1 gig per second. Or this PCI Express is faster, so we're not limited. So IOPS then improve. NVM is basically non-volatile memory, right? You have volatile memory, which is RAM, which means when you shut off the computer and turn it on, it's no longer in memory. Non-volatile memory is if you shut it off and turn it back on, that the items are still stored there, right? Because we want our hard drive to store our items after reboot. So this is the newest out. It's faster than an SSD. And in fact, it's called an NVMe SSD drive. So because there is no, it's solid state, there's no spinning parts. But this is the newest drive out. So I also wanted to talk about RAID a little bit. I'll try to get this in the screen so that you can see it. So basically what happens is a server has a bunch of disks right here, right? So there's a whole bunch of disks, but those disks operate as one and not independently. So, which means like if I have, let's say, 1 terabyte per disk, right? I don't have 1 terabyte times 1, 2, 3, 4, 5, 6, 7, 8. Let's say there's 16. I don't have 16 terabytes of space, right? I cannot use all that raw space because what I'm doing is I'm doing what's called a RAID. So I'm taking the disks and I'm either striping the disks, right, which means data will go across them, or I'm mirroring them, which means disk 1 has data on it, disk 1 has a mirror, right? So instead of having 2 terabytes of space, I only have 1 terabyte for those 2 disks. And there's different types of RAIDs. The most common are 0, 1, 5, and 1, 0, which is a combination of mirror and striping. 1, 0 has become probably the standard for servers, as well as 5. But what happens is, and why they do that is as your people or users or you are storing data on the server and a hard drive goes bad, I don't have to shut off that server. Like, so let's say this is disk 1 and this is the disk 1 mirror. I can pull that out and replace it as it's on, and then the mirror will then begin again. So there's no loss in data, and that's primarily why servers have that RAID standard. It does require some hardware to do. You need a RAID card to plug into your drive so that they can all communicate and stuff like that. So when you're doing this discussion on storing in the cloud or storing locally, these are some things to consider, right? Most of the time people say, well, you store to the cloud for redundancy so you don't lose the data if your item crashes. So my argument to that is that if you have a server on premise, right, you have a server in your server room and you're storing your data on there, and let's say these are all SSD drives, then you're not hurting in performance, and you have that redundancy, right? You have that availability will not be compromised if a drive goes out or whatnot. But on the flip side of it, when you do have a server in the server room and you go home for the day, you can't access that data, right? You can't just click and go to your server without some type of virtual private network software to get back into your company. Whereas a cloud provider, you can access that as long as you have an internet connection, right? So the other con to a cloud, or the against on a cloud, is that you have to have an internet connection, right? You can't just open up your computer and let's say you're at your daughter's gymnastics or somewhere else. You have to connect to the internet to get to that cloud service provider to get the data. So there's a lot of arguments on why you should be able to keep your data on a local hard drive or in the cloud. Expand your thoughts to not only just your laptop and you using it, but your business, and you're an IT professional and you need to look at backup plans, you need to look at redundancy and what's a better fit, right? Or if you're just a user, you want to talk from the user's perspective, will a local hard drive not be for storage anymore? And with regards to a user, a lot of them will get an NVMe drive nowadays, and that doesn't have a lot of capacity for storage. That laptop will boot up using that speed of the drive, and then you'll store to the cloud, right? Because that NVMe doesn't have a lot of capacity for storage, or that SSD. Well, I can tell you, if you do Google nowadays, they are increasing that capacity, right? So you can buy SSDs with a terabyte of space. They tend to be a little bit more pricey, but certainly you can do that. So there is that capability. Finally, you should think about how you want to secure your data. Is your data secured in the cloud? Is your data more secured on your laptop? As an IT professional, is your data in a server room more secure than in a cloud? So there's definitely conversations to have about this. So what I ask you to do is dive into that book, read about the drives, do some research about pros and cons to storing data, and have a good discussion. All right, thanks class. Bye.